cylindrical and spherical coordinates. We're going to talk about how to convert between those two and the rectangular coordinate system. First problem is you're given a rectangular point 0, 5, 1, and you want to convert it or write it as cylindrical. Rectangular is x, y, z. Cylindrical is r, theta. Well, I didn't mean to write it there. Cylindrical is r, theta, z. Well, I'll jump on to z. I know z is 1. Now, r squared is x squared plus y squared. Well, I know x and y. X is 0, y is 5. They gave me that in the rectangular. So it's 0 plus 25, 25. Well, r squared is 25. R is 5. Okay, I have r. Now, the tangent of theta, because now I want to find theta, the tangent of theta is y over x. And I have y and x. It's 5 and 0. This is undefined. The tangent of some angle is undefined, pi over 2. Pi over 2. Theta is pi over 2. It's undefined at pi over 2. That is, we want to do tan inverse, but we can't do tan inverse of undefined. Theta is the tan inverse of undefined. It's defined to be between negative pi over 2 and pi over 2, the tan inverse. If it's undefined, we'll call it pi over 2. And that problem is over. You have some conversion formulas. X equals r cosine theta, things like that. And you convert. Let's do another one. The rectangular is 1, square root of 3, and 4. And we want cylindrical, which is, well, we don't know. That's x, that's y, and that's z. We want r, theta, and z. Well, let's jump on the z, get part credit at least. They gave you z. Now, r, might as well just write down the formula for r. It's the square root of 1 squared plus the square root of 3 squared. 1 squared is 1, square root of 3 squared is 3, square root of 4 is 2. R is 2. Okay. The tangent of theta is y over x, which is square root of 3. The tangent of what angle gives you 3 over 1? The square root of 3 over 1. Tangent of this angle is square root of 3 over 1. That's a 2. Ooh, this is 60 degrees. It's 180 divided by 3. Theta is pi over 3. You have to remember your trigonometry. Special right triangles. 1, square root of 3, 2. Okay, so we have their cylindrical coordinates. 2, pi over 3, 4. The z value comes for free. Here it is. You can have it. Now, how about we go from cylindrical to rectangular? They give us 5, 0, 2. Remember, x, y, z, r, theta, z. Well, we have z. Now, we know that r squared is equal to x squared plus y squared. That is x squared plus y squared, 25. We have that. Okay, we don't know what x or y is, but we know that they lie in their circle of radius 5. And we also know that the tangent of theta, which is 0, the tangent of 0 is y over x. But the tangent of 0 is 0. The tangent of 0 is 0. Well, if a fraction is 0, that means the numerator is 0. Okay, so y is 0. Y is 0. Let's put it in before we forget. So x squared plus 0 squared is 25. X squared is 25. So x is plus or minus 5. And you're like, plus or minus 5. And then you realize, oh, theta is 0. See, we know that y is 0. So either we're at here or we're at 5, 0. But this angle would be pi. This angle is 0. That angle would have been pi. So we know it's positive 5. Coincidentally, they're equal. I mean, it's a big coincidence. Because you can't say, well, of course they're equal. No. That's radians, and that's the length of a side. Okay? You don't have that 2 radians equal 2. That's not true. It's just a coincidence. The units don't match. It's like 3 feet equals 3 yards. No, they don't. No, they don't. 3 equals 3, but 3 feet doesn't equal 3 yards. 3 containers of milk does not equal 3 Hershey bars. And if in some strange way they did, it's only because 3 containers of milk cost the same amount as 3 Hershey bars. Okay, cylindrical. The cylindrical is 4, 7 pi over 6, and 3. And you want to know what the rectangular is. Remember, r, theta, and z. X, y, and z. So of course, they gave us z. Thank you. Now we have to play games with system of equations. We know that x squared plus y squared equals r squared, which is 16. Okay? So we made some progress. If we knew x, for example, we can find y. Now, we also know that the tangent of 7 pi over 6, whatever it equals, is y over x. Now, 7 pi over 6, that's way out here. To go, try that again. It's a little bit more than pi, excuse me. Pi over 6 more than pi. Here's pi. I go pi over 6 more. This angle, pi over 6, 30 degrees. 1, 2, square root of 3, negative, negative. The tangent of pi over 6 is negative 1 over negative square root of 3. It's 1 over square root of 3. That does not mean that y equals 1 and x equals square root of 3. Remember, 1 over square root of 3, I can multiply top and bottom by whatever I want. You have to understand that. Up to k. Now cross multiplying. Oh, so I know that y is no cross multiplying, set the top's equal. for some value, for some number k, y equals k, and x equals k times square root of 3. And if you know that when you divide y and x, you get 7/3. Now, if I double top and bottom, I get this. Sure, if y is 14 and x is 6, that's 7/3. But it will have to be something like that. Maybe I have to multiply by 5. It will be 35 over 15. This is also 7/3. They have to be, y is some multiple of 7 and x is that same multiple as 3. You're given the ratios. That is, whatever y over x, whatever y equals and x equals, when you reduce them, you get 7/3. Okay? Whatever y is and whatever x is, when you reduce them, you get 7/3. Okay, with this information, and x squared plus y squared equals 16, with this and this, I can now answer it. I know that x squared, okay, that's x squared plus y squared, that equals 16. 3k squared plus k squared is 16. That is 4k squared is 16. 4 times 4 is 16. So k squared must be 4. So k is, and here we go again, plus or minus 2. Now, you have to think, if the angle is in quadrant 2, in quadrant 3, x and y both must be negative. So we reject their positive. K is negative 2. So rewriting these, y is equal to k, and x is equal to k square root of 3. So now I have x and y. Negative 2 square root of 3 and negative 2. And just for the record, I think we said that y over x had to be 1 over square root of 3. Well, if y is negative 2 and x is negative 2 square root of 3, what do you know? Negative 2 over negative 2 is 1. I am getting what I'm supposed to get. K cannot just be any old constant. It has to live up to making x squared plus y squared equal 16 in this particular case. Okay. Now we're going to go from rectangular to spherical. The rectangular is 4, 0, 0. X, Y, Z. And we want to go to spherical, which is, see if I remember, it's rho, theta, and phi, or phi. Now, we know that rho squared is x squared plus y squared plus z squared. So y and z are 0. In this case, it's just x squared, which is 16. Rho squared is 16. So rho is 4. Rho is 4. Doesn't take on negative values. Now theta. We know that the tangent of theta is y over x. We're given y, we're given x, divide them, you get 0. The tangent of some angle is 0. The tangent of 0 is 0. So that's theta. Theta is 0. Now, we are told that phi is the cosine inverse of z divided by x squared plus y squared plus z squared. That is, I don't know why most textbooks write it that way, but that's the reason I wrote it. This is just rho. Plug it in, plug in z, which is 0, rho, which I think was 4. 0 divided by 4 is 0. The cosine of what angle is 0? Pi over 2. Pi over 2. Remember, for cosines, it has to be between 0 and pi the answer. No negatives. So it's pi over 2. Just know the transformations. Know how to go from, know that rho squared is x squared plus y squared plus z squared. R is x squared plus y squared. You need to know these things like you know your name. Rectangular is -2, 2 square root of 3, 4. Again, we want cylindrical, which is rho, theta, phi. Rho is easy. Rho is, no point in finding rho squared. We'll just find rho. You square -2, you get 4. You square this number. 2 squared is 4. Square root of 3 squared is 3. 4 times 3 is 12. Plus 4 squared is 16. You get 16 plus 16. I wouldn't say 32. I know the square root of 16. It's 16 times 2. I know the square root of 16. I do not know the square root of 2. I mean, if you say the square root of 32, then you're going to have to say, well, how do I break down 32? The answer is 16 times 2. But you had that. 16, this is 16, plus another 16. That's 2 16s. Okay, nonetheless, rho is 4 square root of 2. The tangent of theta is y over x, which is negative the square root of 3. Tangent is defined in quadrant 1 and 4. So we are in quadrant 4 to be negative. This is over 1. Tangent is opposite over 1. This is 2. This is a 60-degree angle, better known as 180 divided by 3. It's negative 180 divided by 3. But they only want positive answers, I suspect. So how about 2 pi minus pi over 3? This here is 6 pi over 3 minus 1 pi over 3 is 5 pi over 3. You don't want negative angles. It actually makes sense. Now what is phi? Now phi, in my opinion, that's the hardest one to find. Because everyone out there is saying, no, it's not. That's the easiest one to find. Cosine inverse of phi. That, of course, makes no sense. Phi equals cosine inverse of z over rho, which is the cosine inverse. Now, z is 4. Z is 4, and rho is 4 square root of 2. So, it's the cosine inverse of 1 over square root of 2. which I think you should know is 45 degrees. 45 degrees is 1 square root of 2. And the cosine of 45 degrees is adjacent over hypotenuse. 1 over square root of 2. So it is pi over 4. Few more. So spherical to rectangle. You have 12 negative pi over 4 and 0. Which makes no sense. This is spherical. Rho, theta, phi. We want to go rectangular. So we want to go to rectangular. We want to go x, y, and z. Well, we know that x squared plus y squared plus z squared is equal to rho squared. Rho is 12. 12 squared is 144. Okay? Now, we know that the tangent of negative pi over 4 is negative 1. The tangent of the angle is y over x. That means y over x equals negative 1. Negative 1 over 1. That means y can equal to negative 1 and x can be 1. Or you can multiply by k. Or you can multiply by k. So we know this. But that's not enough to solve the top one, because I can write this just using k's, and that's a constant, but I still need x. I still need z. Well, phi, which is 0, is the cosine inverse of z over rho. And rho is 12. Now, the cosine of this angle should be that. The cosine of 0 is 1. This is 1. Excuse me. It's 0. This implies that z over 12 is 1, which implies z is 1. Z is 12. 12 over 12 is 1. So now we have z. Okay, we have z is 12. But you know what? 12 squared is already 144. This means that x squared plus y squared must be 0. But that implies x is 0 and y is 0. 0 and 0. Now, if you wanted to check this problem, for example, you know that the tangent of the angle should be y over x, which is 0 over 0. This does not imply necessarily that the angle is negative pi over 4. If you think about it, we never use this. We never use this at all. We never used the fact that the angle was negative pi over 4. In fact, we got x, y, and z independent of knowing the angle. That is, this angle here could have been anything, and it still would have been 0, 0, 12. it still would have been 0, 0, 12, which is kind of interesting. Sometimes it doesn't matter what the angle is. Suppose you had spherical is 4 pi over 6 pi over 4, and you want to go rectangular. So when you have rho, theta, and z, and you want to know x, y, and z. Well, you know that x squared plus y squared plus z squared is rho squared. 4 squared, 16. The tangent of the angle, tangent of theta, namely pi over 6, on one hand, that's 1 over square root of 3. On the other hand, it's y over x. That means y is some constant times 1, which is just a constant, and x is that same constant times square root of 3. That way, I guarantee you, y over x, just look at it. K over k is 1. I'm getting 1 over square root of 3. There's no other way of getting 1 over square root of 3. Now, we know that phi cosine of inverse of z over rho is phi, pi over 4. So the cosine of pi over 4 is z over rho. But the cosine of pi over 4 is 1 over square root of 2. And z I don't know, but I do know rho. Rho they gave me at the beginning. They said rho is 4. So multiplying both sides by 4, that tells me z is 4 over the square root of 2. Multiply the top by square root of 2, multiply the bottom by square root of 2. You get 2 square root of 2. Z is 2 square root of 2. Okay. Armed with this equation and this and the value for z, we're ready. X squared, x is k. X squared plus y squared plus z squared must equal 16. K squared plus k squared is k squared. Square root of 3 squared is 3. Get 3k squared. Plus 2 squared is 4. Square root of 2 squared is 2. You get 8. 8 plus 8, 16. This is 8. It's also 4k squared, but it's 8. 4 times what I just circled equals 8. What I circled must be 2. So therefore k must be plus or minus the square root of 2. Now, we're told that in the xy plane, the angle is pi over 6. This is quadrant 1. That means x and y are positive. Y is equal to the square root of 2. X is equal to the square root of 2 times the square root of 3, which is the square root of 6. Well, I'm done. I know what x is. I know what y equals. And I now know what z equals. 2 square root of 2. Very mechanical type problems. Just something that students like. Okay. Well, we went from spherical to rectangular, rectangular to spherical. we went from rectangular to our cylindrical, from cylindrical to rectangular. We've always dealt with rectangular. Now we're going to leave that one. We want to go from cylindrical to spherical. 4 pi over 4 is 0. And we want to know what this equals in spherical coordinates. Remember, that's r, that's theta, and that's z. And I want to know what rho, theta, and phi is. Well, I'll jump on the theta since it's pi over 4. Now, remember, rho squared is x squared plus y squared plus z squared. But that's r squared. That is, rho squared is r squared plus z squared. Well, I'm given r, I'm given z. It's 4 squared plus 0 squared, which is 16. Well, rho squared is 16, then rho is 4. And we have rho. Okay. Now, phi is equal to the cosine inverse of z over rho. We have z is 0, rho is non-zero. The cosine inverse of 0, which is pi over 2. Pi over 2. Let's try some more. Negative pi over 6, 6. R, theta, z. And we want to go to rho, theta, phi. Negative pi over 6. Rho squared is r squared plus z squared. It's x squared plus y squared, which is r squared, plus z squared. That's rho squared. So rho is just the square root. It's 4 squared plus 6 squared. The square root of 52, which is 4 times 13. I know the square root of 4. I have no idea what the square root of 13 is, nor can I break it down. It's 2 times the square root of 13. Now, what is phi? Phi is the cosine inverse of z, which is 6, excuse me, z over rho, which is 2 square root of 13. That's 3 over square root of 13. That is not a friendly value. It's not one of those special values. And since math is an exact science, we're not going to ruin that by putting down an approximation. There it is. Okay, let's go the other way. Suppose I give you 10 pi over 6 pi over 2, where that's rho, theta, and phi. It is spherical, and I want you to go to r, theta, z. Well, they gave us theta. Not going to turn that down. Now, we know that rho squared is r squared plus z squared. And rho is 10. You know what? Let me not use square root. So rho squared, which is 10 squared or 100, equals r squared plus z squared. Okay, that helped us. Now, phi is the cosine inverse of z over rho, which is the cosine inverse of z over 10. Well, they tell us that this is pi over 6. Pi over 2, excuse me. They tell me it's pi over 2. Because they said phi is pi over 2. So the cosine of pi over 2, which is 0, must equal to z over 10. But that implies z is 0. If a fraction is 0, the numerator is 0. Okay, so now I have 0. 100 is equal to r squared plus 0 squared, which is just r squared. R squared is 100. So r in the radius is 10. R is 10. And z is 0. And there's your answer. Let's try one more from cylindrical to, from spherical to cylindrical. Negative pi over 6, pi over 3. Rho, theta, phi. And we want to get a cos r, theta, and good old z. Well, we know theta, they gave it to us. Thank you. Rho squared, 6 squared, is equal to r squared plus z squared. Phi, which is pi over 3, is equal to the cosine inverse of z over rho, which is 6. But that means the cosine of pi over 3 is z over 6. The cosine of 60 degrees is 1, 2, square root of 3. This is square root of 3 over 2. I didn't mean to say that. Z over 6 is that. This implies that z over 6 is the square root of 3 over 2. Multiplying both sides by 6, z is 3 square root of 3. So I have z, 3 square root of 3. But now with this and our knowledge of what z is, I can figure out what r is. 36 is r squared plus this squared. 9 times 3, 27. This must be 9. After all, 9 plus 27 really is 36. 9 plus 37, try that again. 9 plus 27 is 36. So r squared is 9. R is 3. 3, negative pi over 6, 3 squared is 3. Okay, so suppose you come to know that r is equal to 2, and this is in cylindrical. That's just cylindrical equation. R is equal to 2. And you want to find the equation in rectangular. You want to find the equation in rectangular. Okay? Well, this implies that r squared is 4. But r squared is x squared plus y squared equals 4. So r equals 2 is x squared plus y squared equals 4. Now, suppose you're told that y is equal to pi over theta is equal to pi over 6. Now, you know this is cylindrical. You know this is a brand new problem. You know that the tangent of theta is y over x. So, the tangent of pi over 6, which happens to be 1 over square root of 3, is y over x. There is your equation. You can clean it up a little bit. You can multiply both sides by y, and you get y is equal to, multiply both sides by x if I said that wrong. Y is equal to x over square root of 3, or square root of 3x over 3. I wouldn't be thrilled if you left your answer like this, but I don't think I can mark it wrong. It is right. Unless your teacher makes a big deal. Don't leave the answer like that. Okay. If you were given this in cylindrical form, I'd multiply both sides by r. Left side will be r squared. The right side will be 2r sine theta. But I know r squared is x squared plus y squared. And r sine theta is y. There it is. You can complete the square in it because it is a circle, but that's fine. If you were told that r squared plus z squared is 4, this one's piece of cake. Just don't panic and know your definitions. Know that your change of vocabulary. These are just vocabulary problems. How do you say r squared? Oh, x squared plus y squared. Oh, plus z squared equals 4. Oh, okay, there it is. This is in cylindrical form. Remember, cylindrical form is r, theta, z. There's r and z. Nobody says you have to be given all three. Okay, a couple of more problems. This time, giving you an equation in spherical form. We want to go rectangular. Well, this implies that rho squared is 4. But rho squared is x squared plus y squared plus z squared, which equals 4. Suppose I tell you in spherical form that phi is pi over 6. Well, that implies that phi is equal to the cosine inverse of z over the square root of x squared plus y squared plus z squared. But this implies that the cosine of this angle is equal to this mess. Z over the square root of x squared plus y squared plus z squared. Cosine of pi over 6, I think, is square root of 3 over 2. That equals z times this. Well, that's definitely rectangular. I don't see r's or thetas. I just see x's and y's. If I square both sides, the left side will become 3 over 2. If I square the right side, it's z squared over x squared plus y squared plus z squared. If I do something I hate to say, if I cross multiply, I get 3x squared plus 3y squared plus 3z squared is equal to 2z squared. Something went wrong here. When I square this, I should get 4 on the bottom. So the right hand side should be 4z squared. I anticipated that happening, and then it did it. Taking away 4z squared from both sides, I get this. And there is the equation of the plane. Let's try the last problem. Rho is 4 cosine phi. Again, the instructions are to find an equation of rectangular coordinates for the equation of the spherical coordinates. Well, if I multiply both sides by rho, I get rho squared is 4 rho cosine phi. And rho squared is x squared plus y squared plus z squared equal to 4 times that. You need to know your vocabulary. That's z. Okay, there's going to be a page in your book that gives you all of these translations. It's just a dictionary. Right? Other than multiplying both sides by rho, which was somewhere clever, I mean, you have to know to do that. But from this line, all I did was say this is that. That's vocabulary. 4 is 4. And what's in this box is z. You have to know your vocabulary. And of course, if you could bring the 4z over, so right now the right side 0, add on half of that squared, which would be 4 to both sides, and you get x squared plus y squared plus z followed by half of that number, which is 2, squared equals 4. This is the sphere that's centered at what makes this 0? 0. What makes this 0? 0. What makes this 0? 2. That's r squared, so r is 2. It's centered at 0, 0, 2, and the radius is 2. Okay, good luck with this. Thank you.